Now we officially start our Space Day in English, and my name is Sanja Stjepanovic. I am a coordinator of this event. I come from the organization of Montenegrin Studies Abroad, OMSA.
I'm Alexander Jacimovic. I'm here as the executive director of the organization of Montenegrin Studying Abroad. This is a young initiative that was advanced by the students. Many Montenegrin students were studying in countries all over the world, from California all the way to Japan. We have a numerous membership, but also we're taking care of a much larger population. We call them CSI, the Montenegrin Studying Abroad. They are very amazing people, and like Sanja is your host for the night, and I'm here. I have a great honor to introduce Sanja as one of our point of contact for Helsinki and Finland and Baltic region. Sanja is a PhD student in Aalto University, and she's one of our first members, one of our founding people who worked with OMSA from the start. What is very important to say about OMSA is that it's just getting the momentum, and we are very much appreciative of all the people who know other Montenegrin students who study abroad to connect to our website and join our common work and our research energy. OMSA is all about information sharing and networking, and creating a very strong network that can support Montenegrin society in its development from all over the world by transferring the knowledge and transferring the resources and lobbying for the causes that can help develop Montenegrin society. And we have a great human capital that is waiting to be explored abroad. And thus far, we are operating in 16 different countries, local countries, and we're taking care of around 500 people who are CSI. That's from me. I just wanted to introduce the organization. I would now give the word to Sanja as the main host of the evening. Please have an applause for the lady.
Thank you. Once again, welcome. We are really happy to see you in so large number tonight. We are very pleased. And before starting our event, I would be really happy to thank to our partners and supporters. First of all, to the Ministry of Science, which enabled us that our event is part of Open Science Days and that we can be here tonight in this nice space. After that, we want to thank to our main partner, which is the Embassy of United Arab Emirates in Montenegro, and as well to the French Institute in Montenegro. So, what is the idea behind Space Day? Most of you might be surprised, how come Montenegro and space? But we wanted to bring some new ideas to Montenegro and show that space industry and space science are actually, even for so small countries such as Montenegro, interesting, and you can see that many of you might even find possibilities to join that sector. And we bring 5 experts from space domain, young experts coming from different areas in the space sector, who will tell you about their life, about their work, progress, success, and hopefully inspire you for one new space idea. So our first speaker for tonight is Mr. Ashley Dale, who comes from UK. And Ashley will present to us about sending human manned mission to Mars and about different implications of such idea. Welcome, Ashley.
Is this on? Yeah, okay. And this one? Is it on?
Actually, you have to switch it on. Yeah.
It's on. Ah, okay. Okay. I was born in the Kalahari Desert in Namibia to a South African mother that was stricken with malaria at the time in what they called a hospital. After my birth, for the first couple of years of my life, I spent my time being taken to and from the hospital because my little lungs couldn't really deal with the humidity in Namibia and the dust in the air. And as soon as my parents found themselves jobs in South Africa, we moved down there. And the environment in South Africa is much like here in Montenegro. Okay. I lived on the coast of Cape Town, absolutely beautiful. Having the beach for a back garden was great, but being the early 90s in South Africa, it was not a particularly easy time. We were robbed many times, typically at gunpoint. Our record was 3 robberies, 3 house robberies in 2 weeks. It was quite bad. But a lot of people had blood on their hands. Even Nelson Mandela. He was not put in a prison 20 kilometers off the coast of Cape Town for 27 years for peaceful protesting. There was a lot of conflict, and even my mother was a commander of a riot control squad in Cape Town. So it was an interesting time. But things for us changed. Things for us changed. My mother's father died, and we moved into the mountains of South Africa, into the Amatola region, to support her mother. I'm not sure what's going on. Yeah. So we moved into the mountains, and things were quieter there, but being the only white kid in a school of 200 black kids was character building, to say the least, immediately post-apartheid. And I had to grow up quite quickly in this environment. It was not exactly conducive to an academic education. And for some years, I did not go to school. The time I spent outside of school, I was lucky in that our village had a little library. Library being a generous word, but it had some books inside, and for the several years that I was outside of school, I dare say that I read every book in that library. And outside of that, I roamed around the mountains as a kid with the dogs and really fell in love with nature. To be fair, living in a subtropical rainforest and not falling in love with nature would be more of an achievement, but I did. It developed me. And that is where I discovered the sky. Okay. As a small kid, finding out that those little dots in the sky were actually vast nuclear furnaces at distances in kilometers greater than the number of words that have ever been spoken in the human language on this planet. And that some of that light that was blasted off those stars had traveled all of that distance just to get caught in my eye. It blew my mind as a kid. Fast forward a decade, my mother found a job in Los Angeles and she remarried to quite a brave Englishman. I spent my time hopping around schools in South Africa, in the United States, in Belgium, and in the United Kingdom. Traveling through all these countries, I came to realize that the rules by which you live your life, the rules by which you're supposed to conform to in those countries, they're not really real. And in that instability, growing up, I sort of developed a stability in myself. And starting out in Namibia, San Bushman of the Kalahari, education in the Amatola Mountains with the Xhosa tribes. I now am in the ivory tower of academia, finishing up my PhD in aerospace engineering. It's been quite a journey already. I now live in Bristol, a lovely city. I'd recommend going to it. Not too long ago, I was part of a crew of mostly NASA and ESA scientists and engineers and architects. And what we did was we were put into an astronauts on Mars simulation study in the high altitude desert of Utah for 2 weeks, constantly being observed, being put through psychological studies, protocol studies, selection procedure studies for astronauts. Oh, I wish I didn't have so many slides. This used to be fixed. Yeah. This was the Mars Desert Research Station. It's a module where they conduct astronaut on Mars simulations, developing field tactics for astronauts on Mars. Next slide. And whilst they were conducting these studies on us, we were conducting our own research there. And if you go to the next slide, please. And again. It's a beautiful region, and it was chosen particularly because of its geological likeness to Mars. So it allowed for a lot of hardware testing to be done with rovers and other types of instruments. Could we move on, please? Next, please. And again. An amazing landscape. Keep going. It was a very intense experience, and I, as a first-year PhD student at the time, somehow getting onto this really quite highly qualified crew, how did I do it? Well, my advice to you, whenever you're going to be faced with any real long-shot applications, as eloquently as possible, drench everything with passion. I will be leading another crew early next year into the simulation, again with some NASA and ESA scientists and engineers. And we'll be field testing a Mars Rover. We will be field testing a Mars drone that's being tailored to fly in the very thin Martian atmosphere. We've got some astronaut suit technologies that we'll be testing. We've got some field work we'll be conducting where we'll be trying to make rocket fuel out of the desert soil, a feasibility study. We will be conducting extreme weather testing on microbes, microbe candidates that would be used in terraforming the Martian atmosphere. We're doing a lot of good things. But my actual research for my PhD is into the future of aircraft design. morphing aircraft, green aircraft, but I'm not going to talk to you about that. Next slide. Creating greener aircraft. Looking at my research, trying to find a motivation for my research when I started out, I came to realize a problem that we're facing. It's really quite obvious when you think about it, but nobody really talks about it day to day. And this problem is that the world we live on, it's finite. It's the resources on our planet that we share are limited. Working on greener aircraft, making aircraft use less fuel and produce less greenhouse gases is still commendable, I think, but don't be fooled into thinking it is a solution to this problem that we're facing. It's simply a speed bump. The world we live on is eventually going to collapse if we continue to live the way we do. It's almost like the law of entropy. We have these resources, we engineer the environment to our liking instead of living in lockstep with the environment around us like the rest of the animals. This is a real problem. Next slide, please. And the problem is in sharing our resources. In effect, if we remain locked to the planet, we are effectively each other's enemies, fighting for the remaining resources on the planet. A war, organized war, is not some human instinct or breakaway from rationality. It's a highly planned and elaborate, highly cooperative form of theft. And as Carl Sagan once said, an organism at war with itself is doomed. So what do we do? What are our options? Well, before I get there, there will always be issues that we face today that are of apparent greater importance to us than space. But I think that we need to find the right balance between our near-term and long-term problems. There will always be poverty, there will always be people suffering. Just by the nature of the way we see things, we will just be moving these yardsticks around. Poverty today is not what it was 100 years ago. But we will always have these differences. And as I say, I think we need to find the right balance between looking at near-term and long-term problems. And with the world spending 7 times more on cosmetics today than it spends on its space agencies, I question whether we have the right balance. Next slide. So, what am I trying to say to you? What do I think we need to do, or we need to think about quite seriously? And that is, we need to think about Mars. Mars is the next logical step for humanity. It is, compared to the moon is like Greenland was compared to America in the previous age of exploration. Don't get me wrong, the moon would be very useful for testing hardware and systems that would be used for Mars, but it simply doesn't have the resources that a technological civilization needs. Mars does. It has all of the materials, all of the irons that we use today. As a civilization, the moon does not. Next slide. And with a relatively small push from humanity, there is a very real possibility that we could change the environment on Mars to something we could actually live on. Next slide, please. You know, an unexpected consequence of the Apollo era, where the Americans were set on getting a man to the moon and back, was that at every level, from high school through to PhD, the number of students in science, in engineering, in mathematics, the number of students throughout the Apollo era doubled. And then after the Apollo era, it dipped off again. What they did inspired a generation, and to double the scientific literacy of your nation in a world that is so dependent on science and technology was a very good move for the US and turned them into what they are today. Next slide. I'm not trying to say humanity is doomed. This might come across as quite depressing at the moment. I mean, when you think of it, NASA budgeted how much it would cost to set up the architecture around, to build the vehicles and to launch the first mission to Mars. They made a budget of how much this would cost them in the early 90s, and it came to about $50 billion. We've had the technology to go to Mars for nearly 2 decades now. Nothing needs to be invented. What does $50 billion mean in context for the United States? Well, $50 billion is 2 weeks worth of the US defense spending, the annual defense spending. And there have been over 1,000 weeks since they put together this plan. And I've spoken to more than a dozen astronauts, a great deal of the leading figures in the space agencies around the world, and asked them all one question: why have we not got people on Mars yet? And they've all answered with one response: it's political inertia. There is no real will to do it in the West. But I am confident that we will get there. Next slide, please. I'm not saying humanity is doomed. I do think we'll get there, because what I am actually saying is, do not assume that we will go to Mars on NASA or ESA rockets with NASA or ESA astronauts. As Jacob Bronowski once said, humanity has a right to change its colors. If America doesn't take the next step, it will be simply taken by somebody else. America has not been given any guarantees that superpowers of the past were not given, like the Assyrians or the Ottoman Empire or the Egyptians. Next slide, please. Humanity needs to go to Mars. Our time is limited. I'm confident it will happen. We must, to survive, or we must evolve back to our pre-Stone Age existence, living in lockstep with the environment like the rest of the animals. We only have 2 options. Obviously, I choose that we need to spread. But maybe it's just the red sands of the Kalahari Desert calling me home. Who knows? Thank you.
Thank you, Ashley. And after hearing about why people should go to Mars, we will have the next speaker, Michael Johnson, Dr. Michael Johnson from Ireland, who will be telling us about robots, about swarm robots and their applications for the research on Mars and in space. Welcome, Michael.
Thank you. Hi. Thank you very much. Okay, I'm here today to talk about robots and rovers, automated robots that will be used to explore far reaches of space, we hope. So hopefully everyone can understand my Irish accent. Right? If you need me to talk slower, do this. If you need me to speak louder, do this. Okay? Okay, next slide. Okay, so in the next 20 minutes, I will hopefully cover what are robots, what do we mean when we say the word robot. I'm going to talk about a particular type of robot, swarm robots. Okay, a very brief introduction to Mars Rover, where it is at the moment, and where it will hopefully go in the future. Okay, so next slide. Okay, so hold on. Okay, so first off, what do we mean when we say robot? Okay, so next slide. Okay, so there are many definitions for the word robot. Okay, the original word came from Czech. It was used in the 1920s in the play. Okay, one definition is a machine that imitates a human. Another definition is a machine that has intelligence, sensors, motion, and energy or power. Okay. Next slide. Right. Using those definitions, there are many machines out there at the moment that can be termed robots. Okay. They vary from the Lego Mindstorm, which comes in at €250 per robot, to the Mars Rover, which comes in at $2.5 billion per robot, and everything in between. When I say the word robot, what you're probably picturing is maybe one of the robots on that page. Okay, movies, TVs, right, especially in the last 20-30 years, have basically colored our perception of what robots are and what they're capable of doing. Go on, right? But surprisingly, the science fact or the actual real-world robotics is catching up really well with what Hollywood would have us believe robots are. Okay, for example, go back a minute, right? On top left here, we have Tokyo. It's a ping pong playing robot. It's able to play ping pong against a human, and it's able to learn. So the longer it plays, the better it gets. Okay, Asimo here is a robot developed by Honda. It's a personal assistant robot. It has conducted the New York Philharmonic Orchestra on its own, unaided. Big Dog is a Boston Dynamics robot at the moment in development. It is capable of basically acting as a robotic pack mule. It's able to stabilize itself over uneven territory, travel at 4.5 miles an hour, and basically carry 150 kilos of weight, okay, for soldiers in the field. So the one area of robotics I want to focus in on is where I'm researching at the moment is what's called swarm robotics. So next. Okay, so what's a swarm robot? Very simply, they're very simple robots, but there are many of them. Okay, each robot is very basic. It doesn't necessarily have a lot of complexity in it, but there is an entire fleet of platoon of robots working together to do a task. Go on. Right. The robots work together as a unit, and by working together, they achieve the goal or the task that they have been set out to. So that could be to find water, to map the terrain, to search for signs of life on Mars. Okay? They work together and they go on task. Again, Hollywood, put on. Hollywood has kind of, what's the word, cashed in on the swarm robotics phase as well. So a good example is the Droid Army from Star Wars. Okay? Individually, each robot, really basic, really simple. But put them all together into one big army, right? And they can conquer planets. Okay, next. This is an example of some swarm robots that are in use today. Typically, a swarm is 10 or more robots. So if I have 10 robots working together, technically I can call it a swarm. Okay? They can be land, sea, or air-based. So I can have a swarm of robots in the sea, up in the air, or on the ground. Next. Okay. So I'm going to switch back now and look at planetary explorers, so robots that are being used to investigate planets in our solar system, and at the moment that means Mars. Okay, go on, right? So Mars is the only planet or the only object in the solar system that we have sent automated robots to at this stage. Okay, we've sent 4 robots to date to Mars. Right, the last 15 years we have had 4 different robots up on the red planet. It is 350 million miles away. A signal from Earth takes 14 minutes to get to Mars, 28 minutes if you need a response. So there's no such thing as fast reaction. Okay? Said there were 4 robots. Sojourner was the first one. That was in 1997. It was part of the Pathfinder mission. It explored the planet for 3 months and it weighed about 10 kilos. Spirit and Opportunity were the next robots sent. They were sent as a joint mission 3 weeks apart in 2004. They weighed about 180 kilos each, which is twice the weight of an average male. Okay, no, go back, right? Spirit is stopped functioning as of March 2010, so it's defunct. Opportunity is still running. Opportunity has gone 20 miles now over the Martian terrain, and Curiosity is the current rover that's up there, and that's actually done 25 kilometers to date, right, in traveling around Mars. Okay, right. The name Curiosity came from an essay competition that NASA ran. A 12-year-old 6th grader from Kansas won the competition and got to name the robot. She chose the name Curiosity. Its official title is Mars Science Laboratory. Okay, next. Right. It weighs 900 kilos or 1,900 pounds, which is about the weight of a Mini Cooper. So a small hatchback car is about the same weight as your Mars Rover. Your iPhone is 4 times more powerful than the Mars Rover. Okay? Your home PC is 10 times more powerful. So, as you can see, $2 billion, they didn't necessarily get the best deal, but they got to put it on Mars, so what harm? Next. Okay. The rover has an impressive science complement or payload. Okay, it has 17 cameras on board. It has a full weather station, so it's able to measure wind speed, humidity, temperature, pressure. It's got a radiation detector, so it's basically able to detect radiation. It's able to take soil samples, analyze them for minerals, water, and/or life. Okay, next. And there are 2 future Mars missions being planned. The one on the right is the ExoMars mission, which will hopefully land on Mars in 2018. Okay, that's a mission run by Russia and ESA, the European Space Agency, and again, its mission is to search for signs of life. This guy here is the next generation Mars Rover, which will hopefully be in development for 2020. That will be launched and hopefully arrive sometime in the 20s on Mars. Its mission will be to search again for signs of life, but this time going back over thousands of years. Okay, and hopefully it will also send us back samples of Mars soil to Earth. Okay, so that's where we are at the moment with the Mars rover and rovers in general. So we are going to now take a step forward and say, what's the future? Okay, so what could we do? Okay, and particularly, what can we do if we use something like swarm robots? So instead of sending 1 rover, why don't we send 10 or 20 or 100? Okay, next. Right, so why would you send multiple robots? Well, 1, they get the job done faster. If I'm looking to map the surface of Mars, it's going to take 1 robot hundreds of days. It's going to take 2 robots half that time. It's going to take 10 robots a tenth that time. So the more robots I can send, the faster I can get it mapped. Okay, next. The more rovers I have, the more ground I cover. Okay, the more interesting stuff I can find. If I'm looking for signs of life, I have a better chance of finding it. If I'm looking for water, I have a better chance of finding it. Okay? Each robot will have a sensor on board. So the more rovers I have, the more sensors I have on the planet. Okay, so again, the more probability I have of finding interesting stuff happening on Mars. Next. If you do it right, the more robots I make, the cheaper each robot becomes. Okay? If I make one robot, it costs me a certain amount of money. To make the second robot is a lot less. To make the third robot, less again. Okay? So ideally, I want to be making however many rovers I need to be basically having an optimum price out of them. Next. Right? And the final thing is, they're fault tolerant. If one rover breaks, okay, it's broken, but I have 19 others, or I have 29 others, or however many, okay? And potentially, I can get a robot to fix another robot. So, from that point of view, okay? These are some examples of robots that are either in development or in use at the moment, and are actually potential candidates for swarms, okay? The interesting ones, this guy up here is an idea proposed by Marco Pavone from NASA. They're called reduced gravity rovers, and the idea is that they would be exploring, say, the moons of Mars, or basically objects with reduced gravity. They bounce around like a beach ball, okay? And they're able to travel a really long distance between touchdown, okay? So they're able to cover a lot of distance in a very short time. Okay, go back for a minute. Right, the guy down the bottom here is being developed by MAST, which is a multi-autonomous science and technology group in Georgia Tech in Atlanta. It's basically a robotic spider. Okay, they are currently developing a swarm of them to essentially, as they say, go places where humans cannot go because of access or because it's too dangerous, right? Mars cannot access it and it's too dangerous for it at the moment, so they're a prime candidate. Moving on to the next slide. There are a lot of very cool robots out there, okay? Really cool, and a lot of work has gone into them, and this is only, as I said, a very brief sample of them. The hexapod here, right, is a robot that is in development. It moves around on 6 legs. You can turn it upside down, it will automatically right itself, okay, and be able to move. It can tuck its legs in, form a sphere, and it can roll around the ground. So it has dual means of locomotion. The guy in the bottom right is called a sand flea. It's developed by Boston Dynamic. It rolls around on its wheels, but it also has a spring underneath, which allows it to jump 30 feet in the air. So, as they say on the website, it can jump small buildings in a single bound. Okay, moving on. Right, so that was just a very brief run through what are robots, what are swarm robots, where are robots at the moment in space, where would we like them to go. Okay, 2012 was the 50th anniversary of planetary exploration. Mariner 1 was launched 51 years ago now. Okay, so in 50 years, we have put 4 robots on the moon, or sorry, on Mars. In another 50 years, where are we going to be? Right? Are we going to have manned outposts on Mars? Are we going to be using that as a forward base to explore the rest of the cosmos? Go on. Right? So there's a lot out there that we can explore. Okay, as I said, if we get as far as Mars, we have Jupiter there, we have the moons of Jupiter, Io and Europa, we have Titan and Saturn, we have the outer planets, the asteroid belt. There's a lot out there that we can look at, and as I said, robots are here to stay. They're only going to get bigger and more important in our technology and in our society. So as I said, on that note, I will leave you. Thank you very much for listening to me, and I hope you enjoyed my talk. Thank you.
Exploration is a natural desire of humanity. We need to explore as well as we need to breathe. That's why, as our knowledge is growing, we need to open new doors and going forward, exploring something new beyond Earth. As Konstantin Tsiolkovsky said, Earth is a cradle of humanity, but one cannot live in a cradle forever. So we made our first steps. First space station, first space flight to the moon. But what will be our next destination point? It depends on us. Analyzing other planets, we can make some conclusions. So, the moon has no atmosphere, no water, it has low gravity, and isn't it too easy to explore the moon? So, Mercury looks like a small bowling icy ball, and it's not suitable for life. Next planet is Venus. We know how toxic it is, so again it's not our situation. And giant planets are too far away, they are too poorly studied, and they are made from gas, and Pluto is not a planet anymore. So we have our winner, it's Mars, the most Earth-like planet. But how long will take the mission to Mars? So let's compare. 1 year journey is around 360 days. And round trip to Mars will be 520 days. But it's unrealistic minimum, because in reality it will take longer. Did we have something similar on board of space station? Well, only once one person stayed on board of space station for 430 days. How you can see, there is difference, and this difference is very important. Also, there is a very big difference between interplanetary flight and flight on board of space station. First point is a very relevant time delay which will appear. This delay means that crew members will need to stay without mission control center help. And it means that crew members will need to take decisions by themselves. And also, one very big problem is isolation. Can you imagine living 520 days in the same round of people? Even during this long mission on board the space station, the person was staying alone, but the crew was changing. And here, again, 6-8 people around you, no one else. And this phantasmagoric picture describes isolation quite good. We can see people and some systems, and everything is missing. So, how the isolation will influence on people? How it will influence on their working capacity? I tried to answer on these questions during my experiments within the framework of Mars 500 project, which was a project which tried to simulate a mission to Mars. It consisted from different experiments, medical, psychological, and technical, and there were like 3 stages: 14 days of isolation, 105 days isolation, and 520 days of isolation. So our crew members, they are real people, and as you can see, all crews consist from 6 people, because this number is the most powerful, and you won't find many conflicts between them. So the first, the second, and the third. But how I was working with them, what I was trying to analyze. I was trying to analyze interaction in complex system, astronauts or crew members, life support systems, and environment. Why? Because space station is a man-made ecosystem, and people are living in this ecosystem and can influence on them because they are working with life support systems, and at the same time they are living in this environment, which means that environment influence on crew members. But for this experiment, can you imagine how expensive it will be to build a full-size life support system? Well, is it 10,000? No, of course no. It's even not the price of one system. This number is closer to the price of one system, but we have a complex of them. So as you can see, it's not possible to build a full system. We need more money, more sources, and etc. But at the same time, we need a tool to explore. So I tried a little bit different approach. I was using virtual simulators of life support system. Here you can see our wall system. It is based on closed loop, which means that we try to recycle all cruise waste, and at the same time we try to regenerate all sources. You can see that there are many systems. Some of them were used during missions to Mir space station. Some of them are used during our missions on board of international space stations, and some of them are perspective. But do we have a complex system right now? No, and this is a big problem because for living in space we still need sources, and first of all water. So let's move a bit forward. For analyzing how off-nominal situations will influence on crew, we needed someone who will create this off-nominal situation. So it is instructor. Instructor can give a task to crew members, and crew members are working with him. On this slide, you can see facilities of Mars 100. There are two living models, and one model with supply, and one model which was simulating on surface of Mars for special tests. And our places were in living models. It was two working places for operator, and one place was in instructor's working place, was in a mission control center outside of these models. And you can see how they are looking in reality. This is a working screen for as well instructor as well operator. Instructor can set up some failures using ONS formation button, and our crew members or operators should control environmental parameters and working with onboard systems, which are I will show you one example how our instructor is given creating off-nominal situation, and crew members are localizing them. So instructor can find necessary failure in the list. Then operator can see that there is a failure in certain system and can change some modes or to switch to the system and to localize the situation. You can see that in the system all necessary things are red, and this operator can see what is wrong. And for localization, every time operator needs to switch some devices or to make some manual operation. And at the end, he needs to make sure that his system is working. Well, I could analyze how the crew is working using just visual control. Or I can go to our database and check how environmental parameters are changing. Because if it's there is a failure, parameters are reactive. But for more deeper control, I was using a special device, which was called biomouse. Well, it's only part of this system, and this is a biomouse. It looks like a usual wire mouse with a special sensor, and it looks like magic, but it's not. Look at your palm. Your fingers, they have temperatures, they have pressure and conductivity. So this sensor can measure all these things and give us results. And basically, the procedure is working like a lie detector. So this is not something really new. So how was our experiment? It consisted from 3 stages every time. First was working capacity test, then our operators localizing some failures, and then again they had working capacity test. What for? The thing is that different off-nominal situations create different reactions in human body. For example, we had very easy ephemeral situations, which was just click somewhere on the screen, but sometimes our operators were working as miners and trying to find a leak in the illuminator, which was much more difficult. And also they have a really difficult manual operations. There is a very easy result of our work. You can see how during all experiments working capacity was changing. For example, one of our crew members made a really big progress starting from the very low point and going and staying at the end of the experiment only in high position. But we can see that some of crew members had a very low result. It means that this time they had stressful condition, or they were sick or something like that. Well, but it's not only one result. During 14 days isolation, we understood how important is signal and how important is this time delay I was talking about in the beginning. Also, our psychologist made a conclusion that gender mixed crew is not really suitable for a long-time experiment. During 105 days isolation, we tried to force our crew members to learn more about life support systems and to give us feedback about ergonomic conditions, etc. I can say that this experiment became a small bridge from virtuality to reality for two members. They are preparing to be a real astronauts and astronaut training center in Moscow. And also, 520 days isolation showed us that not everyone can go crazy sitting in a facility for such a long time. Well, I will show you one more example. How can we go from virtuality to reality? My software allows to replace a virtual simulator by a real method. This example shows how oxygen generation system was replaced by its training device. You can find the same device flying on board of space station, or you can find the same device in a space training center. So it's a very small, but from other side, very big step to create a real life support system. It's not only one idea. We can use this software for many operations. We can use it for astronauts training. We can test some perspective systems using this software. We can track failures which can appear on board space station. So actually there are very many questions we can solve with it. And I would say that this experiment led me to the idea that virtual simulators are not used as well as they could be. And I'd like to encourage the audience to use them more. I'm very happy that media and international publicity helped me to show that virtual simulators can be used effectively. Also, I'd like to say that this experiment was just a little drop in the ocean. And I can say that everyone can make a contribution and go forward, starting from small experiments, from virtual models, and going forward, pushing progress. Thank you very much for your attention.
Thank you, everybody. My name is Jessica Flao, and I am here to talk to you about why we should keep exploring Mars. In other words, Mars curiosity. I believe that my colleagues give you already a nice tour of ways we could go to Mars with human missions and swarms of robots. But I think they didn't explain enough why we should go to Mars. And so that's what I'm trying to do today. I'm going to try to do. So when I say Mars curiosities, I do not mean only Curiosity, the latest Mars Rover. But what I want to do is give you a tour of the most exciting science facts about Mars. You might already know some of them, but in order to get your full attention, I added a few special features. So be ready for mind-blowing Mars images and stories. But first, let's start with this question. Why Mars? Why is there so much fuss about the red planet? And why did we decide all of us to talk about Mars today? Well, Mars has been known in many cultures and has been observed for centuries. It has many names in all of those cultures. Even I became fascinated by Mars at a very young age. And I'm not sure I can fully explain how it first started. Of course, Mars is beautiful, right? But I cannot be the only one. I guess that every time I have looked up at the sky, I have wondered what it was like up there, and what was going on, and if we were alone. And I'm probably not the only one that's curious, right? Actually, this last point is one of the most fundamental questions of human existence. And Mars is not only the closest planet to Earth, so the most easy to observe. It's also the most similar to Earth. So maybe where we could find extraterrestrial life? But most importantly, and at least I think that's what titillates me, I find that Mars is the most curious aspect, the most intriguing planet because of its very curious aspect. Okay, I'm missing some text on my slide, I'm sorry, I'm going to explain to you. Unrevealing Mars secrets is not only my biggest dream. NASA decided it would be the next step after landing a man on the moon. That is the reason they designed the Mariner program at the end of the 60s. The Mariner 4 was the first spacecraft to take images of the surface of Mars. A few years later, in 1976, Viking 1 and 2 were the first two landers to ever reach the surface of Mars. They analyzed the composition of the surface, and they showed that Mars was sterile because of the oxidation of the surface, the absence of water, and the presence of UV. This was a very big disappointment for scientists. They decided to turn their back to Mars, dedicating no more mission to the red planet for the next 16 years. So Mars got a second chance only, can you change the slide please? Only 16 years later with the Pathfinder mission. Pathfinder landed on Mars in 1996, so 20 years after the Viking Rovers. Since then we have had four additional spacecraft, 3 rovers and 1 lander sent to the red planet. You could think that after having so many missions to Mars, we should know everything by now about this cold, dry body. But on the contrary, the observation keeps revealing new features, new structure, new faces, raising new questions. So let's see what they ask now. And I want to start with what is to me the most amazing science discovery of this decade so far. The Mars Express instruments have shown that high-protein minerals are commonly detected at the surface of Mars. High-protein minerals are minerals that contain water, H2O, in their structure. So they require liquid water to form. Okay, maybe you will tell me this is the 10th time we have announced we have found water on Mars. And this is true. We actually know since the Mariner mission that there was liquid water in the crust of Mars at its surface, as evidenced by the Valley network. But the high-protein minerals bring us a lot more information. Indeed, depending on how much water is present, the composition of that water, the temperature and pH condition, different minerals are formed. For instance, if you have a warm and wet environment and a neutral pH, you will tend to precipitate clays. On the contrary, the pH is acidic, and you have sulfur that is brought, for instance, by volcanoes. Then sulfates tend to be formed. So studying the composition of Mars rocks allows us to reconstitute very precisely what was the environment like at the time they were formed, and therefore studying Mars climate history. And the story of Mars, as we know it so far, is that the planet likely encountered a major climate change. Clays are commonly detected in the very old terrains that we call Noachian terrains. They tend to form under warm and wet conditions. Sulfates usually characterize the Estonian age sedimentary deposits. They indicate that the surface was likely acidic at the time of that formation. There are no very few hydrogen minerals found in the terrains younger than 3 billion years, suggesting that the planet has been dry since that time. So we basically went from a warm and wet planet to a cold and dry planet, with maybe a transition period that was characterized by an aciditization of the surface. How did it happen? Why this climate change? Well, if any of you can tell me, I promise to reward him or her with a very good bottle of French wine. At least the establishment of this Mars timeline helped us pick a very nice landing site for the latest Mars mission, Curiosity. This small rover you can see in the back. The rover landed in a crater where both clays and sulfates are detected. So we hope that it can study on the field the climatic history of Mars. And in less than a year of operation, one of Curiosity's greatest findings is evidence for non-acidic environment on Mars that are very suitable for the development of life, but also very good for the preservation of biosignatures. So past evidence for life. We have to remain careful though, and I will explain to you why with a very simple question. Do you expect the rocks, let's say, in Canada, to be the same as the rocks here in Montenegro that you have in your mountains? Probably not, right? And that's the thing. The rover only tells us about a very, very small portion of Mars' surface and a small part of Mars' history. This is why we need many more of those missions. But this is also why we need to combine the information collected by the rovers or landers with remote sensing data that are taken by the instruments of the spacecraft from orbit and provide us with a more global view. So talking about remote sensing now, you will see that not only Curiosity is doing miracles nowadays. The IRIS camera on board the Mars Reconnaissance Orbiter spacecraft is a wonderful tool. The camera is taking pictures of the surface from orbit, so at a distance that is at best 300 kilometers, with a spatial resolution of 25 centimeters per pixel. Yes, I said 25 centimeters. That is the size of the object we can see at the surface of Mars, 25 centimeters. That is really cool. It means that the camera could see a man standing at the surface of Mars and resolve his different body parts. Since 2006, the camera has taken thousands of wonderful images of the surface of the planet. Most of them have not even been exploited yet. We just don't have enough scientists to look at all of them. So among these images, we can observe interesting sequences of carbon dioxide ice forming dark spots and gullies with dark linear features. Also avalanches, moving dunes, newly formed craters, current water flows. All of these amazing landscapes actually show us that Mars is in movement. They keep changing over the seasons and years. And this is just a snapshot of what came up in Mars science the past 2 or 3 years. Maybe you have also heard a few years ago about another big discovery, which was the measurement of methane released in Mars atmosphere. People talked about it a lot because on Earth, the prime source for atmospheric methane is biological activity. We still don't know as of today if the methane on Mars is of biological origin, or maybe volcanic origin, or else. And it was actually debated no longer than last week. That was in the newspapers, and maybe you have seen it also on TV. Because the researchers working with the Curiosity rover have shown that they cannot detect the methane in Mars atmosphere. So it raises more questions about what is the survival time of methane in the atmosphere, or if the atmosphere is even homogeneous on Mars. And I don't have time to go too much in detail over all of these recent scientific discoveries. But my point is that most of them were unexpected and remain unexplained. And one of the reasons we were able to make all of these wonderful observations on Mars is because Mars has no plate tectonics. On the contrary to Earth, there is no recycling of Mars crust through subduction processes. It means that all of the rocks that were once produced at the surface of Mars are preserved. They might have been covered, impacted, altered, but they are there. You could find them. Mars contains a unique geologic record that goes back to the formation of the planets in the solar system 4.5 billion years ago. And I really want to insist on this last point, because this is often neglected as everybody is so focused on finding life on Mars. And I agree this is a valuable research, but Mars is not only the most likely planet to host or have hosted life, it also represents an amazing opportunity to study planetary formation and evolution, and find out which conditions prevailed early in the solar system after the planet was formed. So the last images I want to show you today were produced as part of my own research about a year ago. I was interested in looking down the huge canyon of Valles Marineris. Valles Marineris is about 4,000 kilometers long and 10 kilometers deep. For those of you who have ever been to the American Grand Canyon, just imagine a canyon that is 5 times bigger than the largest canyon on Earth. To give you a rough estimate, the walls of Valles Marineris represent a vertical cliff that is higher than Mount Everest, so higher than the highest mountain on Earth. And the extent of the canyon is greater than the distance between Montenegro and Greenland. So this is consequently the greatest, the largest tectonic feature in the entire solar system, and also the deepest natural cut at the surface of Mars. So I was interested in looking down the walls and trying to figure out if this transition that we expect to find on Mars between clays and sulfates, that is indicative of this climate change, could be recorded in the stratigraphy of the canyon. And what I found there was very different than what I expected. I observed some very uncommon rocks that are formed of minerals that come from very deep in the underground. These rocks were interpreted as remnants of Mars solidification 4.2 billion years ago. They should be about that age, 4.2 billion years, which is way older than any rocks we could ever find on Earth. This is consequently a little bit by accident that I identified some of the oldest rocks on Mars and maybe in the solar system. And these rocks are just nicely exposed deep down in Valles Marineris. It means that we could get them, we could analyze them. Just imagine how valuable it would be to land at the bottom of the canyon to analyze those rocks. And just picture the view from there. That would be quite amazing, right? And all we need to analyze these rocks is a friendly geologist who just come by and pick them up. I mean, okay, maybe not that friendly. I know I have to admit geologists tend to work with a hammer. But that's the thing, is that there is a huge potential in this canyon. And I would love to see a mission landing there. Unfortunately, I have to admit that with occurrence, landing capabilities, it's not possible to land in the Canyon yet. There are too much technical constraints and the engineers are not willing to take the risk yet. There are actually many places of Mars that we cannot access just at this point with our current technology. Consequently, we have not explored much of Mars surface or even Mars history. And I think to achieve that goal, that we're going to need more missions, of course, to Mars, to explore new areas of Mars. So for that, we're probably going to need to rely on new technologies. We're going to need to consider, but I think that's my personal opinion, Mars sample return missions, because as a geologist, I would really like to have a piece of Mars rocks, really. And I think for that, we're going to need a lot of new Martian engineers, scientists, coming with new ideas, crazy ideas. And we're probably even going to need some Mars astronauts. Before we can reveal all of Mars' dark little secrets. So who knows? Maybe you can be part of it, and you will. So if there is only one message to take home from this talk, is that we don't know that much about Mars, and there is still plenty to be discovered. I like to think that Mars history is still to be written, and that I can be part of it, and that even you can be part of it too. I think Mars has been popularized a lot by science fiction writers and filmmakers. And now picturing yourself living on Mars in 50 years from now seems like normal for many people. But I want to remind you that we don't own Mars. We haven't earned Mars. And we don't know all about it. So don't think it's acquired. Don't think it's done. We're not done with Mars. Research takes a lot of time. And its conclusions are not frozen. It keeps evolving as a function of the new evidence we found. And we actually have kept changing our mind about what could have happened to Mars. In the 70s, we thought Mars was just a big desert and nobody could live there. In 2000, we thought there was maybe an ocean on Mars. And now we're talking about this climate change, and we're not even sure about it completely. So be careful. I think planetary science and space science in general is a fairly young discipline. A lot has been found over the past 3-4 decades, but a lot more remains to be found in the future. So if I can leave you with only one piece of advice, it's just to keep looking up. Thank you.
Thank you very much, Jess. We are at our final speaker. Let's see where that is not. Okay. So, our last speaker is is signed as my friend also from ISU, from the National Space University. The entire crew that you see tonight here are all people from the International Space University summer program. Sonia and I had an amazing honor to be here as participants in 2012. We were in Kennedy Space Center in Florida, and we are kind of to blame for this entire setting, because we believe that we should share the experiences of these people and also their ideas about where the industry is going to you, and so you can have a better idea of how you, or maybe somebody you know who's very passionate about this kind of information, who you can share this information to, can participate as well at some point. We really believe that we should not keep our heads closed in the society that we are in. We've learned, we had an opportunity to be all around the world and see a lot of options, and we think that this kind of information gathering or information acquiring from in an informal setting like this can be very helpful for everybody. Radosh is a very interesting guy. He's been on basically all the continents on the planet. Yeah, he's ready. You come here. And he's did a very interesting set of talks with a lot of very important, influential people around the world, and he's going to tell you a little bit about leadership. And yeah, thank you very much.
So, I'm the last one. I'm going to start with a beautiful poem. It's a poem written by the Sufi poet Rumi in the 13th century in Arabia. It's a coincidence. And Rumi says that the breeze at dawn has secrets to tell you. So do not go back to sleep. You must ask for what you really want. Do not go back to sleep. People go back and forth between the worlds at that hour. So do not go back to sleep. You must ask for what you really, really want. So do not go back to sleep. And the question is, how many of us really know when they wake up in the middle of the night what they really want to do in life? What is their burning desire, their burning passion? How many of us know how to listen to the voice of the heart speaking to us before the dawn? And how many of us know even during the day what we really, really want in life? Just like many of you here today, I was a normal child growing up in a normal town in Romania, finishing up from a normal university, and starting up in a 9-to-5 job. However, when I was 24 years old, something happened and I lost my mind. At least this is what my parents believed, this is what my friends and colleagues who work in the university, this is what they believed about me. Because one day when we were just having a cup of coffee in a coffee shop, out of the blue I told them, my friends, this year I want to go to explore Antarctica, I want to go explore the North Pole, I want to see the coldest regions in the world. I want to see the glaciers, the penguins, and the northern lights in the North Pole. And I guarantee this was not normal for anyone. And however, when I found myself saying these kind of things, I had many ideas in the past, but this time was different because this time I actually allowed for the possibility that my idea can become real. So I had no money, no high connections, I didn't have any idea of how can I do it. Okay, how you're just a guy from Eastern Europe, how do you travel to Antarctica? You have no money, you don't know who to call, you have no idea how to start. So what I've done, I just began following any idea that came to my mind. So I wrote to every single polar institute in the world to ask them if I can go on one of their expeditions with them. Obviously they said no. I tried getting a job at one of the research centers in Antarctica. Anything, washing dishes, being the truck driver, I would have done anything to do this. Nothing worked. I even called NASA one day asking them, are you willing to take me with you aboard your plane going to Antarctica to deliver supplies? And who is this crazy guy calling us? I would do anything. I tried to get a job on a commercial cruise ship to wash dishes. I was doing a PhD at the time in space engineering, and I said, what if I do a proposal and the European Union gives me money? Nothing worked. I was hoping for a scholarship, nothing. I spent half a year every day for 6 months, day and night, following any idea that came to my mind. And I want to ask you, how many of you know or have experienced the pain that you feel when you have a dream and you don't know how to accomplish it? So you know the feeling, right? Okay. However, as the poem says, the breeze at dawn had secrets to tell me. So I woke up one night at 3 a.m. with an idea. And if you ever get an idea at 3 or 4 a.m. in the morning, usually it happens over and over again. If you get an idea at that time of night, just follow it, because ideas are very powerful that come at that night. Because at that time of the night, which is called the magic hour or the golden hour, ideas come directly from spirit or from the human heart, as some would say. All the mind noise is sleeping, all the opinions of others are sleeping, and the ideas you get at that time of night are very powerful. So this is the naive idea I had. My passion, the easiest thing for me in those times was photography. So I said, why am I not just being honest about who I am, and I ask companies or whoever can take me with them, I'm going to take pictures for you, can you please take me with you on your ship? And I sent an email to every single company in the world who had a ship going to Antarctica. And to my surprise, the great majority of them simply ignored me. How people do. Some of them, they said no. But only one, a single company from South America, the other side of the world, in Chile, they said yes, welcome aboard. You know, when that happened, I couldn't even believe my eyes because I didn't have a professional camera, I had no equipment, but I just sent the idea and they said yes. So anyway, I borrowed all the equipment I needed and I went to explore the South Pole, see the penguins, the glaciers. From there, I flew directly to the North Pole to see the Northern Lights. This is again the North Pole. The idea is that's how powerful your ideas, your actions, your persistence, your prayers, your hopes, your heartfelt desires are. And in the following years, I had many similar ideas, and some of them worked, and some of them were complete failures. For example, I organized with some friends from the Romanian Space Agency the first simulation mission for planet Mars, as my colleague here asked me. And then I finished the best space university in the world, the NASA Kennedy Space Center. But I didn't know what made the difference between projects and ideas that failed completely and the ones that did work. And they worked in a surprising way. So for that reason, I had to learn two things. And usually if you read self-help books, if you go to seminars or attend to lectures, not many people will say this to you, but believe me, it's true. I'm sure that you have experienced them. First of all, following your dreams and following what you want to do in life, it's very, very, very hard. It's hard, it's painful, and the dreams you have are so fragile they can fall apart in any moment. And number two, the pain you have, the pain of you not trying, is a million times more terrible, more excruciating than the pain of you trying and failing again and again and again. So in order to be able to share this thing with you, I had to find out, because I'm a scientist and I don't believe in all the mystical things happening or you can see on the market, I had to find out from the best minds in the world what allowed them to reach such high levels of success. People who spent decades working on their visions, what allowed them to go all the way to the end. I had to find out what was the secret that the breeze at dawn told me and what is telling each one of us. So 6 years ago, I began a journey on 5 continents from South America, North America, all the way to Europe, Asia, and Australia, and down in New Zealand. Speaking to some of the best scientists, some of the best minds in the world, discover how did they do it, how did they think, and how we can do the same. Just to give you some names. I had the chance to speak to work. A dear friend of the person from NASA, the director of NASA, who built Hubble Space Telescope. And he spent 15 years working on Hubble Space Telescope. It's the masterpiece of technology and innovation. It's the crown jewel of NASA and the holy grail of space exploration that National Geographic calls Hubble. I had the chance to work with a professor from Stanford who sent 3 robots to Mars. He's in charge of the Mars project. He put curiosity, he put speed and opportunity, 3 of them together successfully on Mars. And I asked them, what made you persist for decades to work and to fail and to go? Because it's not easy to send a robot to Mars. What allowed you to do all these kind of things? And they told me. And it's one thing and one thing only. Secondly, I wanted to see if this information is complete, because when I was young, I wanted to become a musician. So do musicians work in the same way as scientists? So I had the chance to speak with rock stars. Guitar players like Steve Vai, who turned music into magic with their instruments, and they say the same thing, and one thing only. And then I flew directly to Asia to speak with Buddhist monks. And I wanted to learn from them. What is the secret that they know that allows them to just spend decades walking around without any shoes in the streets of Colombo in Sri Lanka? And simply, everything they were doing is just share their love, their compassion, their kindness, and their wisdom. Everyone could listen. This is what they were doing. And everyone said the same thing. Everyone said one thing. And it's so simple, yet sometimes so difficult to do for us. And that thing is, This is the thing that the prison dawn has to tell you. You have to be in love in life. You have to be in love with what you are doing. And not just at a superficial level, but really deep down in your heart, you have to be in love with what you're doing. All these people, they loved building spaceships. They loved traveling into space. They loved their science. They loved playing music. They loved touring the world with the band. They loved their spiritual journeys. And I have understood why some of projects that I had failed and why some succeeded. Because I was in love with ones that succeeded, and I didn't care so much about the other ones. That's the key. The question is, what do you care so much about in life? What is it that lifts you up and makes you smile all the time whenever you think about it? Now, how many people here are over 18? Many, right? Okay. So, usually as we grow older, we find ourselves meeting the greatest struggle of our lives. Usually, especially in those times, we are filled of anxiety, we are filled of fear about what the future will bring. The media is feeding on our fears. But sometimes, sometimes we try, almost always we fail to answer the question. And the way we answer this question changes everything. And simply the question is, who am I? What's my purpose in life? How can I be more happy? How can we even dare to be happier, to ask for happiness when we don't have the courage to be honest with ourselves? That's the key question that I'm asking grown-ups. How can we ask for happiness when we don't have the courage to live our truth? So the only way to be free in life and to be in love with what you're doing is to have the courage to live your truth, to know who you are and to be who you are in every single moment of every single day. That's what it means to be authentic. That's what it means to be in love with what you're doing, to know who you are and to be who you are in every moment of every day. Are you probably wondering, what's the connection of being in love and doing the things that you have to do in life? And maybe authenticity and doing what you love is like an esoteric concept. It's not so clear. The thing is, we come into this world with the technology inside our bodies that allows us to know from the very beginning if we are heading in the right direction and if we have the chance to go together. And this technology, some people call it the technology of prayer, some people call it the science of bringing miracles into reality. This technology has been removed from our most sacred texts. This technology is so simple to understand. Think about it for a moment. Imagine a horse, a carriage, and a driver. What is the only way for this ensemble to go somewhere together? The only way for them to go together is to go into the same direction. Now, the driver is your mind. The driver doesn't have the power to put the entire ensemble together, but it has the power to give a direction. I'm going that way. The horse is your emotions. It's the raw energy of what you love in life. However, you have all seen how dangerous emotions can be in our world without a mind to guide the emotions. And the carriage is simply our bodies. Without mind and without emotions, it's just dead. But this is the key for the three of them to go together. The moment you align what you think with what you feel and with what you do, the moment you align thought, feeling, and emotion, and this is the whole paragraph, the moment you align the three together, you make them as one. In that moment, you say to the mountain, mountain, move away. And what will the mountain do? The mountain will not go anywhere. But in that moment, you will have found the power within yourselves to climb the mountain all the way to the top. That's the power that we carry within ourselves. When you are true to yourself, when you act as you feel and as you think, that's when you find yourself the resilience to fail, the confidence to fail, to keep on and to keep on keeping on. And when you're authentic and you are true to yourself, in that moment, every hit, every blow you receive will only make you stronger. And I love this quote from the movie Rocky. And Rocky says, in life, it doesn't matter how hard you hit. It only matters how hard you can get hit. How hard you can get hit and continue moving forward, how hard can you get it and continue moving forward. When you are being true to yourself, every hit you receive makes you stronger. But the moment you are lying to yourself, when you are not true to who you are, in that moment you don't stand a chance, because in that moment you have become your worst enemy, because you are attacking yourself from the within. So when you become authentic to yourselves, when you think and feel and you go and you do and take actions in the same direction, in that moment you learn the secrets you don't have to tell you. So, can you put that music a bit louder? I want to leave you the final thought. And we are 7+ billion people in this world today. And from these 7+ billion people, there is no one like you. Think about it for a moment. You are totally and completely unique. And nobody can become you, nobody can be you. And from these 7+ billion people, if you do not become who you are really meant to be, then who can? If you are not in love with your life, who can be? If you don't follow your dreams, if you don't listen to your own heart, who can do it for you? If you don't have faith in yourself, if you don't believe in your dreams, if you don't see how powerful you can be, who can do it for you? And if you don't see the beauty that's within yourself and around you, to the left, to the right, behind you, if you're not kind to yourselves, if you're not kind to the others, there's no one to do it for you. So, before I say goodnight, I want to say thank you. I want to say do not condemn who you were yesterday. I want to say bless the person who you are today, because that's the most important thing. And I want to say dream of the one who you can become tomorrow, because that's the real power that you carry within you, to be who you really want to be. So thank you and good night. Can you come here? Now, before everyone leaves, I want to say one thing. Right side here, come. Who else is in the room from the organizers? I want to say that these people have worked very hard days and nights. They haven't been sleeping in a few weeks to make this possible for you. And I want to, together, if we can share the appreciation for what they have done for us tonight. So thank you so much for your hard work. Now I can go.
Ja ću ipak iskoristiti priliku da nešto kažem ispred Ministarstva nauke Crne Gore. Želim da vam se svima zahvalim što ste došli večeras u ovolikom broju. Bilo je tu nekih improvizacija, došli smo u prostor koji još uvijek nije potpuno osposobljen za ono što smo mi željeli, ali željeli smo da ponudimo nešto što do sada nije bilo tipično u Crnoj Gori. Ja moram da priznam da su i meni dosadna ona duga i teška naučna predavanja, pa smo htjeli da nam ponudimo nešto što je blisko vama, što je moderno, što je urbano i što je onako prilagođeno nekom vašem uzrastu. Nadam se da smo u tome uspjeli. Veliko hvala ovoj ekipi ljudi koja je uradila fantastičan posao. Iskreno se nadam da ste uživali. Hvala vam.
We want to thank to our speakers who flew from so far abroad to come here to speak to us. Hvala i vama svima što ste došli u tolikom broju.
Hvala vam svima. Mislim da to još malo hane, da se podržite. Nadam se da ćemo svi vidjeti opet iduće godine u okviru nauke i on se će raditi mnogo drugih narednih projekata. Oni su obično organizovani od strane omsalaca, ali otvoreni su za sve ostale ljude koji dođe učestvuju. Tako da ako čujete da nešto radimo, slobodno se predvorite. Prijatno večer i używaj weekend.